Hello, my name is Jaime Manresa. I'm from Mallorca, Spain. I'm a junior, and my goal is to be an aerospace engineer. My favorite class in Goshen was electronics because aside from learning the theory behind the complex circuits and their components, you actually have the chance to apply what you are learning in the weekly labs as well as to the final project that you will eventually present to the public. I also think that being able to apply what you learn is essential to the learning process. I think that the faculty blends real well with Goshen and its size. Being a small college allows the faculty members to know their students better and otherwise, and so it makes them to be more approachable. Also, I think that having a great relationship with the professor can potentially be very beneficial. The reason I chose Goshen College is because I think that the idea of having a 3 and 2 program with the University of Notre Dame is really good. Studying 3 years of engineering physics in Goshen gives you a really solid background of physics, so you can actually take on any other engineering that you would like in the University of Notre Dame for the following 2 years.
I'm John Buschert, and I'm a professor of physics at Goshen College. I've been teaching here for 30 years. We have here two programs, physics and engineering physics. Physics, the regular physics major, we've been doing for a long, long time. And that is a program that's designed to sort of prepare you for a career in physics of some kind. You could be well prepared to go and work in a government or an industrial lab. Many of the students that follow that program go on and complete their education in graduate school. And then they may work in industry or in academia in various ways. We have many students, and they have very good success in getting into graduate school from the preparation that they get at Goshen College. The other program I want to talk about is engineering physics. That's a little bit newer, though we've been doing things like it for a long, long time. And that is designed for students in our engineering program. And we have a 3-2 program with several schools. Notre Dame is one of them. Another is Case Western Reserve in Ohio. And students also do this with other places besides. But the idea is you start at Goshen and attend Goshen for 3 years. And during that time, you're learning the basic physics and science courses that any engineer would take no matter where they are. So you take introductory physics, you take calculus, you take chemistry, you take various science courses, but you also take many other courses. You take courses in writing, in history, in economics, in whatever the other areas are that you want to broaden yourself into. Because the idea of this program is that you're not just getting a narrowly focused engineering preparation, but you are also learning to think critically. You're getting broader skills. You have an appreciation for culture, for history, for aesthetics, and we teach you about all of those things, and you get experience with those things. You would be part of our SST program and go and learn in a foreign country. So the idea of this is you go to Goshen for 3 years, and while you're taking the introductory courses and the beginning engineering courses, you're also taking these other things and getting a broad foundation of education that will that will serve you well in any field that you go into. Then you transfer. At the end of 3 years at Goshen, you transfer and do 2 years at an engineering school, a program that's well respected and has lots of different opportunities and very specific programs in mechanical or electrical or civil engineering. You get that full technical training as well. You end up there, you're there for 2 years, so the total is 5 years. It's one more year than you might have expected, but you end up with a powerful combination. You get 2 degrees. Goshen gives you a full engineering physics degree. That's a Bachelor of Arts in Engineering Physics from Goshen College. That says you've got the broad preparation, you've got the understanding, the critical thinking skills, and then you also get a BS in engineering from an engineering school that is respected in its own right. That's a powerful combination, and many employers are looking with favor on that particular kind of education, that broader introduction. So that's the kind of program we have at Goshen for you. So you can either do the standard physics and prepare for a career in physics, or you can do this engineering physics and a 3-2 engineering program and become an engineer, but be, in a sense, a cut above some of the other engineering students. So one of my favorite courses is electronics, and actually lately I've been calling it electronics and robotics because it really deals with both. Been teaching this course for a long time, it seems, and we start by introducing everybody to just basic electronics, the circuitry that you have to learn to do almost any kind of electronics, how to work with resistors and capacitors and simple basic circuitry. And that's mostly analog circuitry. We learn about how to use transistors and op-amps and such and build amplifiers. And then we, at the same time, introduce digital electronics, working with simple gates and on-off circuits. And then, in addition to that, we add the ability to program a circuit. And these days, we work with Arduinos, which are a little board that you can program. You write a program on a regular computer and you upload your program into the Arduino. Here's an example of one done by a group of students, and I don't know how well you can see it, but down inside here is a tiny little blue board, and it's got a chip on it, and that's the Arduino board. And you can connect that board to sensors. In this case, I've got it connected, well, the students have it connected, to a rangefinder out here that's going to sense the distance to an object. And you can connect it to things that do things. So here is a little RC servo motor, and so that can move this arm back and forth as a way of letting us know how far things are. So let's turn it on. The batteries are a little low. I don't know how well it's going to work, but as I move something back and forth in front of here, you can see it responds some of the time, and it doesn't respond other times. There it goes. There it's going some of the time. I think the batteries are low at the moment, but you can see it's responding. And the idea is you could park your thumb on this and move it around and sense where are the walls and where are close objects, where are far objects, and just like that I can see, oh, something's real close, and there things are far away. And the intent of this is to build a little tool for a blind person to be able to just scan around and see where are things if they come into a room that they're unfamiliar with. That's an example of a circuit built by a couple of students in the electronics class, putting together all of the different knowledge they have and then actually building a little device that might even be of some use to somebody. The class is a fun one because you do all this learning. At the beginning we have a series of labs that introduce you to all of the different aspects of electronics, and you learn them. And then about 2/3 of the way through the course, that all stops. And everybody is focused on building some kind of a project like this. This was one of the projects of of a couple students, actually. Usually you're working in pairs. And they do some kind of a project, try to build something, get it to a final state where it is demonstrating how it works, a sort of very early prototype stage or something like that. Get to that point so that you can show people how this might work. And then we have a show. And so everybody on campus is welcome to come. The public is invited. And we have usually several hundred people that come through gradually and just look at all the different projects and see what the students have created. And it's great fun. And it's a real challenge for me and for the students to get everything ready at that point. We're all working toward this goal because the date of the show is fixed, and so everybody has to have everything working by that time. But we've learned using benchmarks. I have students working ahead to plan. We've got to get this working by that time and something else working by another time, and by the final week everything has to be in working order. And by using procedures like that, you learn a lot about what it's like to work in an engineering situation in the real world, where It's not all laid out for you. These are not projects that are pre-planned. The students are figuring it out, and in many cases nobody's done anything quite like this before. So they have to figure out how to put it together and how to make it work. So that's a lot of fun. I want to show you a couple of examples of other projects students have done.